Hi everyone. Today we'll deal with the continuation of number system, which is HCF and which is what HCF and LCM. Okay, which is HCF and LCM. We'll see before going to the LCM and HCF. Uh, we'll understand the meanings first. Okay, so first he is talking about HCF. Okay, HCF. We'll understand this particular thing, while writing, let's say 2, 3. Okay, what are the factors of 2? Can I say 1 is a factor? Yes. So let me write factors this side. I want to tell you something. Let me take, bigger numbers, that will help you a lot. Let's say 6, 24. Okay, 6, 24. What are the factors? 1 is a factor? Yes. 2 is a factor? Yes. 3 is a factor? Yes. 4 is a factor? No. 5 is a factor? No. 6 is a factor? Yes. But 24. 1 is a factor? Yes. 2 is a factor? Yes. 3 is a factor? Yes. 4 is a factor? Of course, yes. 5 is a factor? No. 6 is a factor? Yes. 7 is a factor? No. 8 is a factor? Yes. 9 is a factor? No. 10? No. 11? No. 12 is a factor? Yes. After 12, what is a factor? 24 is a factor. So my point is this. So 6. What are the multiple 6 next? 12, okay, 18, 24, and so on. 24, what are the multiples? 24, I mean like 24, 48, okay, 72 and so on. Okay, 72 and what? So on. 6 multiple is also 6, 24 multiple also 24 and so on. Always remember HCF, concentrate on F, concentrate on M. F which means a factor, okay? F which means a factor, okay? So someone will ask he calculate the HCF of 2, 4. Guys, what is the HCF? What are the factors of 1 and 2 are the factors? Here 1, 2, 4 are what? The factors. Okay. Guys, are you getting my point? So, what is a common factor? Which one is common? Yeah, the common is what? 2 is common. And that is the only highest rate. So you can say HCF of these two numbers is what? 2. Okay. What is the LCM? Okay, write multiples. What are the multiple? 2 is a multiple, 4 is a multiple. Next, 4 is a multiple, 8 is a multiple. That's it. He's asking the common. What is a common one? 4 is a common one. He's asking about least. Well, which one is the least? The first one. The 4 is the least. Please understand, the meaning. So, what do you mean by a factor? And what do you mean by, multiple? Okay, multiple. Okay. So first we'll see first HCF. What do you mean by HCF? Highest common factor. Or you can say, sometimes people used to say that, greatest common divisor of a set of numbers. Okay. This means, largest number that can completely divide all the given numbers. Okay, that's going largest number that can be completely divided all the given number. Okay, all the given number. Let me write clearly. Highest. Okay, which means what? Largest. Okay, largest. Okay, factor. What do you mean by a factor? Okay, factor, which means what? Completely divides. Okay, completely divides. Okay, common means what? All the numbers. Common, which means what, guys? All the numbers. So what if we need to find out the largest number that completely divide, let's take, we'll take few numbers. People is going to ask you what is the HCF of 72, 108 and 126. Okay. We are searching for what? We are searching for HCF of 72, 108 and 126. How we are going to do? Okay, so being it's a first question, so let me write. So 72 and what? 108 and what? 126. We are searching for what? The highest common factor. So let's write the factors. Yeah, 72. What are the factors? 1 is a factor? Yes. 2 is a factor? Yes. 3 is a factor? Yes. 4 is a factor? Yes. 5, no. 6 is a factor? 6 is going to divide with this number? Yes. 7 is a factor? No. 8 is a factor? Yes. 8, 9 is a 72. 9 is also a factor. 12 is a factor? Yes. Okay. Next, 18 is a factor? Yes. 24 is a factor? Yes. So what are the next factors? You can say 36 and 72. So these are all what factors. If I want to write factors of 108, 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor? Yes. 5 is a factor? No. 6 is a factor? Yes. 9 is a factor? Yes. 12? Yes. 13? No. 14? No. 15? No. 16? No. 18? 18 is going to divide with a not 8? Yes. 19? No. 20? No. 21? No. 22? No. 23? No. You can say next one is 27. Next one, if you write, 36. Next one is what? 54. And what? 108. Okay. So let's 126. 1, 2, 3, 4 is a factor? No, guys. 4 is not a factor because 26 is not going to divide with 4. 6 is a factor? Yes. 7 is a factor? 7 ones are 7. Okay. I left with what? 126. No. 7 ones are 7. I left with 56 is going to divide with 7. Yes. 9 is a factor? Yeah, because 3. Yes. 14 is a factor? Obviously, because 10 is not the factor. 11 is not the factor. 12 is not the factor. Okay, 12 is not the factor. Yeah. Next would be 18 because 9 is multiples of 9. Okay. Next is what? 21, 42, 63. If you write it, you can get it because why 63? Half of 126 only 63. So my point is this, friends. What we want, we are searching for what? We are searching for the common factor. 1 is common, 2 is common, 3 is common. So 4 is common, no. 6 is common, yes. So which is common? Yes, all are commons, but our target is what? Our focus is what? High. Okay, the highest one. Okay, the highest one. So which one is the highest? So come from here. 126 is present in common. So 126 eliminated. 108 is common, no. 72 is common, no. 63 is common in everywhere, no. No. 42 is common, guys. 42 here, but 36 here, but 36 is present here, no. So 36 is not going to your HCF. 21 is present here, but 21 is anywhere present, no. 18 is present here, yes. 18 is present here, yes. 18 is present here, yes. So you can say, what is the HCF? What is the HCF, guys? The HCF, the highest common. Okay, the HCF is going to be what? 18. The HCF is going to be what, guys? 18. Okay, so yeah, so that means what? The 18 is the largest number that can divide each of 72, 108, 126. There is, no number higher than 18 that can divide the given numbers. Okay, that can divide the numbers. So you can say the highest common factor of 72, 108 and 126 is what, guys? Yeah, 126 is what? 18. Okay, 126 is what? 18. Okay, where we can actually use this HCF. Okay, HCF. Guys, in situation when a quantity or a number has to be divided into smaller equal groups. Okay, now we would making using of what factors? Examples, there are 120 plants into some equal rows. Okay, 120 plants, some equal rows. How we are going to calculate that? Measuring, some 20 liters using one smaller measuring Yes or no? Divide or cutting a rectangle dimensions 24 into 36 into equal squares without any wastage. These are the cases where the HCF will come into the picture, which means the factor will play the important role. Okay, the factor will play the important role. Okay, the factor will play the important role. Okay, so that's how let's say how the factor will play the important role. In the previous question, the number of rows would have been a factor of 120. Okay, you cannot plant 25 rows after the fourth row, so it has to be what, only a 20 row will not have the same number of that thing. The measuring has to be a factor of let's say measuring of what, 16 liters using one smaller measuring. So the measuring has to be a factor of 15. With 5-liter measuring, we can only measure 5, 10, 15, 20, not 16. So what is the factors of 16? You can say 4 is a factor. Yes or no? 2 is a factor. Okay. So that's how you need to figure it. But what are the approaches to figure out HCF? Okay. How to find the HCF? There are so many ways. We'll see turn by turn. Okay. Finding the HCF. How to will calculate HCF? Method 1. The method 1, that is factorization. Okay, factorization. Yeah, in the previous question we have written the whole bunch of factors. Okay, so this method is called factorization. Okay, how to do it in factorization? I told you. What do you mean by factorization? The given number you have to write in the form of what? Prime numbers. What are the given numbers here in the previous question? 72, 108 and 126. So you can write this as what? 9 into 8. Okay, you can write this as 12 nines 108. Yes or no? So 126. What you can write here? 63 into 2. Okay, so 9 you can write what? 3 square. 8 you can write what? 2 cube. 12 you can write 4 into 3 into 3 square. You can write this as 2 square into 3 cube. 63. 9 7 is 63. So 9 you can write it as what? 3 square. Yes or no? Okay, 3 square into 7 into 2. So you can say 3 square into 7 into 2. So what do you mean by factorization? Convert every number in the form of what? Prime. Okay, every number in the form of what? Prime. So what do you mean by HCF? So please observe what are common in everything. 2 is common in everywhere. Yes, 2 is common here, 2 is common here, 2 is common here. But you need to think that 2 square is common in everywhere? No. So you have to take only 1, 2. And 3 is common in everywhere. 3 is here, 3 is here, 3 is here. Which power is common? 3 power. 3 square is common, 3 square is common. Here also 3 square is common. So you can say 3 square is common. 7 is common everywhere? No. So that's not common. So 2 into 9, 9 2 is about 18. That's only we got HCF now in the previous case. Instead of writing the whole thing, okay. Obviously, this method is called, the textbookish way of solving, but I can say this is the appreciated way of solving. Okay, we can say this is what? Appreciated way of solving. Okay, yeah. We are finding the highest common factor. Then why do not take the least power? Shouldn't we take the least power? Look at here. While we are finding the highest common factor, more importantly, the required number should be a factor of all the numbers. Okay, if we take the highest power of a prime, 2 cube, in this example, it would not divide 2 or 2 square. Yes or no? Yeah. But the least power would definitely divide the highest power. Okay. Yeah, that's what. So don't take the highest power as a common. So you have to take the least, because if you take highest power as common, 2 cube as common, that will not divide 2 square into. But you take the least one, 2, that will divide all the, because the concept is factorization. Okay, the concept is what? Factorization. What is the approach to? Approach to, highest power of primes that divide all the numbers. Highest power of prime, that divide all the numbers. Okay, if the numbers are very easy, like above example, what are the examples? 72, 108. Okay, 72, 108 and 126. Just find the highest power of the primes. Just find the highest power of the primes. That can divide each number. Okay, each given number. Dividing each of these numbers will ensure a common factor, and taking the highest power will ensure will the largest number such. Powers of 2. Guys, powers of 2. Guys, the powers of 2, 7 to 2 can be divided by 2, yes, 4, yes, 8, yes. Okay, now, so what is the highest power? 8. So you can take 2 cube here. That's what he's saying. 108 can be divided by 2, yes, 4, yes, 8, no. Okay, 126. What is the highest power of 2, guys? 2 only, because this will not divide with 4. Okay, that will not divide with what? 4. Okay, what is the power of 3? Power of 3. 72 can be divided by 3. Let me write clearly. For 72, I am writing powers of 2. Okay, powers of what? 2. 72 can be divided by 2, 4, 8. 108. For 108, 2 and 4 only. Yes or no? For 126, only 2. Okay, what is the power of 3? Yeah, the power of 3 is going to be for 72. 3, yes. 9, no. Yeah, 9 also, yes. Yes, sir. For 108, 3, yes. 9, yes. 3 cube is what, guys? 27. This number is going to divide with 27? Of course, yes. Okay, for 126, it's going to divide with 3? Yes. 9? Yes. 27? No. In the previous one, you can say here what is the highest power? The highest power, you can say what here? 8. Yes or no? What is the highest power here? What is the highest power? But the point here is what? The highest power here is what? 8. Okay, but 8 is common in everywhere? No. So which one is common? 2 only common, no? Yes or no? Yes or no? Are you getting my point? So this is also one of the way you can solve it, but I can say the previous method is the best method. Okay, you can do like this also, but you should have some clarity while solving it. Okay, you should have some clarity while solving it. Okay, so stick to that method. Otherwise, in school days we used to do like this. Let's say if you want HCF of 2 and 3. So 3 here, so 2. 2, 1 is 2, and you are going to get like that. It will take again it will take a time. Okay, we will try to solve a question. Please write down a question. Find the largest number. Find the largest number on dividing 85, 150 and 220. Leaves a remainder of, when you are find the largest number, which largest number is going to divide 85, 150 and 220, leaves a reminders of 1, 6, 4 respectively. Okay, 1, 6, 4 respectively. How to tackle these type of questions. Whenever you come across these type of questions, the only point is this, guys. 85 some number is there, when that number is divided by 85, remainder is what? 4. Which means the number on dividing 85, remainder is what, guys? 1. Which means, can I say the number definitely divides 84 completely, no? Yes or no? So definitely the number is going to divide what? 84 with what? Completely. Okay. And what is the next number? 150. What is the remainder? 6. So can I say that particular number definitely divides 144, no? Yes or no? The particular number definitely divides what? 144, no? Yes or no? Next number is what, guys? 220. So if you divide 220 with some number, what is the remainder you are getting? Remainder is what? 4. Which means it completely divides what? 216. It completely divides what? 216. So which means you need to figure it out, which number, which highest number which will divide 84, 144, 216 completely. Okay, completely means which divided this number, the highest one. So you need to figure it out, the HCF of 84, 144 and 216. Okay, so he'll give the option. So from options you can verify this. Otherwise, I have given the methods to figure it out this. Okay, how to figure it out this 84. 84, how I can write 12, how many times? 12 sevens, 144 also I can write 12 into 12, no? Can I write this as 12 into something? Yeah, 12 into 14 you are going to get this. 14 tens of 140, no. 12 into 16, 16 tens of 160, 16 twos are 32, no. 16 into 18, 18 tens of 180, 18 twos are 36. Yes, this is what 16 into 18. So which one is common everywhere? Yes, which one is common everywhere? 12. So guys, look at here. Guys, you need to understand this is what 12 into 7. It is obvious that 7 does not divide the other numbers. So checking for 12, we find the other numbers definitely divisible by 12. Okay, so HCF of 84, 144 and 216 would be what, guys? 12. Otherwise, you can do in the previous method also, you can do it. Okay, you can do it in that method also. Okay, so what is the so otherwise, generally in a textbookish way, yeah, let's say n is a number, n on dividing 85, it's leaving a remainder. It leaves a remainder. Okay, it leaves a remainder of what? 1. So you can say 85, which is equals to n into a plus 1. Okay, which means that is equals to 84 is equals to n into a. That's what happens. And n on dividing 150 leaves a remainder of what? 6, which means 150 is equals to n into b plus 6. So you can say 144, which is equals to n into b. N on dividing 220, what is that number? Yeah, 220, which leaves a remainder of what, guys? 4. Okay, which means 216, which is equals to n into c plus what? 4. So that is equals to what, guys? Okay, sorry, this is what? 220, right? Yeah, so that will give you 216, which is equals to n into c. So which one is common? N is common in everywhere. Okay, so n is a common factor of what? 84, 114, 216. We want to find out the largest such number. Okay, so that's how this is a general form. Algebraically we can write like this. Okay, but it is not necessary to write it. Okay, yeah. So we'll try to solve with the next question. We'll try to solve the next question. Yeah, please write on the next question. Please write on the next question. Yeah. Find the largest possible three-digit number. Find the largest possible three-digit number that leaves the same remainder that leaves the same remainder that leaves the same remainder when it divides 145, 277, 673. 673. Okay, 673. Find the largest number that on dividing 85. Oh, sorry. Find the largest possible three-digit number that leaves the same remainder when it divides 145, 277, 673. Guys, we don't know that, let us assume the number we want to find to be n. Okay, I don't know the number. So number, okay, what we are finding, please assume it as what? N. Okay, n. And the common, okay, remainder in each case, because the remainder in each case, what is saying, so assume, remainder in each case must be r. Okay, so we can say, so can I write 145, which is equals to n into a plus r? Yes or no? Obviously. So 277, which is equals to n into some factor into what? Because r is going to come everywhere. So 673, n into c plus what, guys? R. Okay, r. So if you closely observe, if you do, let's say, this is first equation, this is second equation, this third equation. If you do 2 minus 1, so 277 minus 145, 277 minus 145, that will give you 132. Yes or no? 132. And obviously r will get cancelled. So you can say nb minus na. So you can write this as 132, which is equals to if you take common nb minus a. Okay, if you do 3 minus 2, how it's going to be? Yeah, 673 minus 277, that's going to be what? 369, which is equals to nc minus nb. So you can write it as 369, which is equals to n of c minus b. Okay, and if you do 3 minus 1, okay, 3 minus 1, that's going to be, because this is a larger number, no? So 673 minus 145 will give you 600, 528. So 528, which is equals to nc minus na. You can write it as 528. Okay, 528, which is equals to n of c minus a. Guys, if you look at it here, so definitely n has to be a factor of, n has to be a factor of, can I say 132, comma 369, comma 529, no? Because n into something is going to be 132. So definitely n has to be a what? A factor of what? Because there is no remainder will come into the picture, so it's all about a number. Yeah, so finding the HCF of these means what? 132. You can write 132 as, can I write 11 into 12? Yes or no? Are you getting my point? 11 into 12. Checking of these two numbers are, checking of the other two numbers are divisible by 11 and 12. Okay. We find that, they are, So the largest number that can take is what, guys? The largest number that n take is what? 132. So check, 132 is dividing 145, 277, 66, which leaves a remainder 13. Let me check. Okay, so 132 when divided with 145, when 132 is dividing with 145, what is the remainder? 13. 132, 132, if you divide with, okay, if you divide with 277, okay, so 132 double how much? 132 into 2, you can say 2, 4, 267. The difference is what again? The difference is what? 13. So you can say that n value will take what? 132. Okay, the n value will take what? 132. Okay, so you need to figure out that particular 132. If you multiply 132, so that's going to be your HCF. Okay. Okay, so the largest value, the largest three-digit number when divided. So what is the largest three-digit number? 132. That is going to divide with 145, 277, 673. That will give a remainder of 13. So in each case, that is giving a remainder of 13. Yes. Okay. Okay, that's how we can try to get the answer. He is going to ask you. When the HCF will be given, then the numbers are unknown. He's going to ask you how many pairs will be there. Okay, how many pairs of that particular thing will be there. Okay, then how to tackle these type of questions. These type of questions. Let's say we'll try to solve this. Let's say if HCF of X, Y and Z are given to be H. Okay, are given to be H. Okay, it should be obvious that H has a factor of each of the numbers of X, Y and Z. Obviously, no. Those, can I say, X, Y and Z should be multiples of H? Obviously. So we can say that X is equals to HA and Y is equals to HB and Z is equals to what? HC. Hence, since H is the highest common factor, so A, B and C should not have any further common terms, obviously. Yes or no? Because H is the common factor, so it is obvious that A, B should not have any other further common terms. Or else you can say that would be also common to the three numbers, and the HCF would be no longer 2H, but it would become what? H into the common term. Okay, H into the common term. He's going to ask you like this. Yeah. Write down a question. How many pairs of numbers exist such that their HCF is 12 and the sum of the numbers is 108. Okay, there are numbers and their HCF is what? Given 12. If you add the numbers, the sum of the numbers, okay, the sum of the numbers is going to be what? So pair of number is saying, so he's saying only two numbers, 108. So pair, he's saying, guys, the numbers are assumed, the numbers are assumed as, can I say, 12A, 12B? Obviously, there is a pair. So if one changes, if you put A and B values full, so that the HCF should be what? 12. And if you add, so you can say 12A plus 12B, which is equals to 108. Okay, 12a plus 12b, which is equals to what? 108. So from this you can say, if you took 12 as common, it's going to be a plus b, which is 108. So from this you can say a plus b, which is equals to 12 how many times? 9 times. Yes or no? So a plus b value must be what? 9. So let's take a and b. When a is 1, b must be what? 8. Then only the sum is what? 8. This is 2, this must be what? 7. When this is 3, this must be what? 6. Yes or no? This is 4, this must be what? 5. Is there any, when I take this is 5, this is going to be 4. Again, this is going to become. So how many pairs are there? Okay, how many pairs are there? So, guys, you need to understand here is, you need to understand here is, but thinking that there are 4 such pairs is wrong. Okay, if you think there are 4 such pairs is wrong. Why 4 such pairs are wrong? Look at here. The value of 3 and 6. Look at here. The value of 3 and 6. Okay, so 12 into 3, 36. Okay, 12 into 6. Okay, 12 into 6. When I took this, guys, look at here. When I took this, the common factor is not 12. I can say the common factor 12, 3 is a 24, because you can write this as 3 into 2 as well. Yes or no? Then 12 and 3, 12 and 3, that is going to be the highest common factor. Okay. Okay. Are you getting my point? Are you getting my point? Then the highest common factor will become what? Then the highest common factor will become what? 12, 3 is a 24. Those, among the solutions we got, we have to check to see A and B not have any common factor. Yeah, after getting A and B, further is there any common factor? You have to see 3 and 6, any common factor is there? So this pair is going to be not in your pair. 4 and 5, is there any common factor? No. 2 and 7, is there any common factor? No. 1 and 8, is there any common factor? No. So you have to say there is only 3 pairs. You have to say there is only what, guys? 3 pairs. Okay, there is only what? 3 pairs. This is how you can do your HCF part. Always think factor, which means which divides completely divides. Okay, completely, which divides completely is going to be your answer. Okay, yeah. Wait a minute, guys. Wait a minute, guys. I want to show you this particular thing actually. Yeah. The important words are factors. What do you mean by factors? Factors are numbers that divides all the given numbers. Multiples. Multiples are the numbers that are divided by the given numbers. Okay. Common factors. Common factors are the numbers that are divided. Divide the given numbers. Multiples of the numbers that are divided by all the given numbers. So please, these are the important words. Pause the video and try to capture the data. Next. Yeah, please, this is what important. HCF is nothing but the largest number that divides all the given numbers. Okay, all the given numbers is called what, guys? HCF. LCM is nothing but the smallest number that divide, the smallest number that is divided by the given numbers. Okay, factor is going to divides, multiple is going to divided by the given numbers. Okay, that will divides all the given numbers, that is divided by the all the given numbers. So these points are important, friends. These particular points are very, very important when you are looking at here. Okay, divides all the given numbers, divided by all the given numbers. This is going to divide all the given numbers. So factor, multiple are two important points here. Okay. Okay. Chalo, next. So these are the important points. Yeah. So yeah, I'll come to these slides again one more time. So before that, I want you to continue with this, LCM. LCM. Guys, least uh, common multiple. Okay, least common multiple of a set of numbers. That is the smallest number that can be completely divided by the all the given numbers. Okay, completely divided by all the given numbers is called what, guys? That's going to be what? LCM. So least, which means the smallest. Okay, which means the smallest multiple. Okay, multiple, which means what? Is divided by common. Okay, common, which means all the numbers. Okay, all the numbers. Okay, so someone asks you to find the LCM of 6, 10, and 15. So 6, what are the multiples? 6, 12, 18, 24, okay, 30, 36, 42, 48, okay, 54, 48, 54, 60, 72, and so on. You can write 10, 10, 20, 30, 40, 50, 60, and so on. 15, 30, 45, 60, and so on. Yeah. But your concentration should be what? Multiple. Yes, all are multiples. Common. 6 is common here? No. 12 is common anywhere? No. 18 is common anywhere? No. 24 is common anywhere? No. 30 is common. 30 is here? Yes. 30 is here? Yes. 30 is here? Yes. Common. And he's asking what the least one. There are common multiples will be present, but you need to figure it out what the least. Look at here, 60 is also common multiple, but this is the least. No, what is going to be least? The first one which comes first, that is going to be the least. So you can say 30 is the what? HCF. Okay, 30 is what, guys? HCF. Okay, when we are going to use, sorry, LCM, when we are going to use LCM actually, you know a clock striking every 10 minutes, or a bus leaving every 10 minutes. When you think of a question, you will understand whether you want the multiples or the factors. Okay, whether you want the multiples or the factors. A traffic light, a neon signboard. For every for every 2 minutes a traffic light is blinking. For every 1 minute the neon light is blinking. Okay, how to come across these type of questions. When a clock is striking for every 10 minutes, means it will strike where 10 minutes, 20 minutes, 30 minutes, all the multiples of 10. Okay, are you getting my point? So a bus is leaving for every 10 minutes means, yeah, 10 minutes, 20 minutes, all the multiples. Okay, the light is blinking 2, 4, 6, 8, all the multiples. Okay, so that means that's where your answer is there. So after uh, reading the question, you will understand, that's where your answer. Please ask yourself a question, whether you want a multiple or a factor. If you want a multiple, choose LCM. If you want a factor, choose HCF. That's it. Okay, then what are the approaches? Okay, this approach is there to calculate LCM, that already. So what is the next way of solving? Again the factorization. Okay, again the factorization. Okay, again the factorization. How the factorization, okay, will how the factorization will come into the picture? Let's say someone asks you, find the LCM of, find the LCM of 24, 40, and 54. Okay, whenever you come across this, factorize it. Okay, factorize it. 24. How you are going to write 24? 8 3 is 24. Yes. How you can write 8? 2 cube and this 40. How you are going to write 8 3 8 5 is 40. 80 means what? 2 into 5. 54. How you are going to write 8 54. Okay, 7 5 is 35. 7 6 is 42. 42 plus 7 49. 49 plus 7. No, that is going to give 56. No. Yes or no? So how you are going to write this? Yeah, 9 27 into 2. Yeah, 27 into 2. So 27 you can write what? 9 cube, 9 3 cube. So 3 cube into 2. Yes, 27 into 2 only 54, no? Yeah. So whenever you want LCM, okay, okay, since you know what we are looking for, what a multiple. I know which of the following, we would have to take the highest power of each of the prime present in the above, which means, here. Okay, we need to looking for what? The highest common factor. So 2 is present. What is the 2 highest power, guys? 2 cube. What is the 3 highest power? 3 cube. What is the 5 highest power? 5. Okay, so 8 into 9 into 5. Okay, 9 8 is 72 into 5. Okay, 5 2 is a 10, 1 carry, 7 5 is 31 plus 1, 36. So you can say LCM is nothing but what here? 360. Okay, LCM is nothing but what? 360. Okay, LCM is nothing but what, guys? 360. Okay, okay, LCM is nothing but what, guys? 360. And application of LCMs, he'll give you, if the question is like this, okay, he'll give, there are different situations will come into the picture while solving the LCM questions. Okay, LCM questions. Yeah, let's say the question goes like this. The question goes like this. Find the series of numbers. Find the series of numbers that when divided by that when divided by that when divided by 12, 18, 30, 30 leaves a remainder of 5 in each case. Leaves a remainder of 5 in each case. Okay, each case. Okay, each case. These type of problems are characterized by the remainder being the same in each case. Okay, so whenever you come across these type of questions, if you want the series of the problem, so what you are going to do is, so you need to write LCM of divisors. LCM of divisors. Okay, LCM of divisors into some constant plus the common remainder. Okay, plus the common remainder. Okay, the common remainder. Okay, the common remainder. Okay, what is the logical explanation for this? The LCM of but what is A? Where A is nothing but 0 1 2 3 anything. Okay, the whole numbers. Let's closely look at here. Closely look at here. The LCM is the least number that is completely divisible by the divisors. Yes or no? If we add the required remainder to the LCM, those will always, left over the remainder or no? Yes or no? So that means what you are going to find, you need to find the LCM of 12, 18, 30 with a constant and plus 5. So what is the LCM of 12, 18 and 30? Yeah, if you figure it out, 12, 18 and 30, 12 you can write 3 square into 4, sorry 2 square into 4, yeah 2 square into 3, 18, 6 3s are 9 2s are, so 3 square into 2, 30, 15 into 2, 3 into 5 into 2, so the LCM must be what, 5 into 3 square, 5 into 3 square into 2 square, so 5 into 9 into 4, 9 45, 45 into 4, 180, so 180a plus 5. So if you want the series of numbers, guys, if you want the series of numbers, the smallest number, so if I substitute a value 0, so the smallest number is what, 5. If I substitute a is equals to 1, let me write clearly. So I got what, LCM of 18, what is the other number, 18, 12, 18 and 30, so this into plus 5. Okay, so LCM what we got, so 180a plus 5, the series of numbers when a is equals to 0, so 5, when a is equals to 1, so this is 180 plus 5, that will give you 185. Okay, when a is equals to 2, that goes continue, 18 2s are 36, 360 plus 5, okay, 365, that's how you can get, okay, that's how you can get your answer. Okay, if you want, you write, algebraical way of expression, you can write it. Okay, you can write it. How you are going to write? The number which is equals to 12a plus 5, 18b plus 5, 30c plus 5. Okay, so from that what you can write? 12a is equals to n minus 5, 18b is equals to n minus 5, 30c is equals to n minus 5. So n minus 5 is what? A multiple of 12, 18 and 30. Okay, so that means you need to figure it out, the LCM of 12, 18 and 30 plus 5. Okay, LCM of 12, 18 and 30 plus 5. So this is the case 1. What is the case 1 we are talking about? Find the number. Okay, find the number when the remainder in same. So here the remainder is same in all the cases. Okay, when the remainder is same in all the cases, what you are going to do is LCM of that particular numbers plus 5, that will give you the remainder. Okay, that will give you the answer. The next case number 2. Okay, when the difference between the divisors and respective remainders is constant. Okay, when the difference between the divisors and respective remainders is constant. How? Write down the question. Find the series of numbers that when divided by 12, 18, 30 leaves a remainder of 5, 11, 23, 5, 11, 23 respectively. Okay, 5, 11, 23 respectively. Okay, guys, whenever you come across a situation like this, what you're going to do is calculate the LCM of 12, 18 and 30, and you need to, and a multiple, and you need to subtract what? The difference. And you need to subtract what? The difference. Look at here, 12 minus 5, what is the difference, guys? 7. 18 minus 11, what is the difference? 7. 30 minus 23, what is the difference? 7. When you are going to approach this method, when the differences are same, okay, then you are going to approach. So what is the LCM of 12, 180 and 30? 180 a minus the difference. What are the differences, guys? 7. Okay, so the smallest number, if you put 0, minus will come, so this is not going to your answer, so put 1. When you put 1 here, okay, so 180, 1 minus 7, the smallest number you can say 173. if you put 2, so 180 into 2, so 360 minus 7, you can say 353, 353, and so on, and so on. Okay, so if you want to solve these type of questions, this what is the logic here? Yeah, what is the logic here? Yeah, the logic must be what, guys? Yeah, the logic must be difference must be same. Okay, the difference must be same, then only you're going to get your answer. We'll try to solve one more example, to get a clarity. Look at here. Okay, write down a question. N is a number. N is a number that on being divided by 3, 4, and 6 leaves a remainder of 1, 2, and 4 respectively. Okay, so you need to find out this. Find the smallest 4-digit value that n can assume. Okay, assume. And the second question, find the value closest to 700 that n can assume. Okay, that n can assume. Okay, that n can assume. So whenever, let's look at here, 3, 4, 6, which are leavings what? A remainders what, guys? Look at here. So 3, the remainder is what? 1. If I am dividing the number with 4, the remainder is what? 2. 6, the remainder is what? 4. Look at here. What is the difference here? 2. What is the difference here? 2. What is the difference here? 2. So can I say, since the difference between the same, so what you're going to find out? You need to find out the LCM of 3, 4, 6. Okay, of A minus the difference. Okay, so what is the LCM? 3, 4, and 6. You can say LCM is what? 12. A minus, what is the difference, guys? 2. Okay, what is the difference, guys? 2. So this is the actual form. So if you put the values, the whole number 0, 1, 2, 3, you will get the series of numbers. But the point is, what is the first question? Find the smallest 4-digit number is asking. Okay, find the smallest 4-digit number. What is actually the smallest 4-digit number? 1000. Yes or no? When I divide this with 3, which is divisible by 3 and 4, this is going to divisible with 3 and 4 because it's definitely a multiple of 12. No, what is the divisibility rule of 12? So 3 and 4. Okay, 3 and 4. So when I am going to divide with 3 and 4, so 1000 is not going to be 12a. So what is the smallest one? 1008. This is going to divide with both? Yes. So the smallest one is 1008 minus 2. So that will give you 1006. Okay, that will give you what? 1006. Okay, that will give you what? 1006. Next, what is your second question? Okay, what is your second question? See, 1000. Okay, because the number has to divide with 12, no? So this is not going to divide with 12,000. Okay, when you divide this number with 12, you will get some remainder. So you will get definitely 8 as a remainder. Okay, look at the next one. The number on either side of 700 that is divisible by 12 which means 3 and 4 is, 696 is going to divide with 12. 7 and 708 is also going to divide with what? 12. But he's asking what the closest value 700, that closest value. If I took 700, okay, the closest one is what? 696 only. He didn't mention after 700 or before 700. So you can say 696. You can say the answer is what, guys? 696. Okay, you can say the answer is what? 696. Okay, so now, so this is all about, LCM. This is all about, LCM. Okay, so whenever you want LCM, look at the multiple. If you want in the question, if you want multiple, go for LCM. If you want a factor, go for HCF. Okay, so we'll see some observations in LCM and HCF. Okay, these observations were only for two numbers. Only for two numbers. Okay, so the first observation, product of two numbers, product of two numbers, which is equals to HCF into LCM. You can actually you can see it. 2, 3. What is LCM? LCM you can say 6. What is HCF? HCF is what? 1. So can I say 2 into 3 is equals to only 6 into 1? Yes. Guys, this is strictly only for two numbers. Okay, only for what, guys? Two numbers. Okay, this is only for what? Two numbers. Okay, next, point number 2. For any set of numbers, okay, for only for two numbers, this is the logic. What is that? Product of two numbers is equal to HCF into LCM. HCF into LCM. Okay, HCF into LCM. Yeah, point number 2. For any set of numbers, the HCF has to be factor of LCM. Okay, for set of any numbers, the HCF has to be factor of LCM. So definitely HCF has to be factor of what? LCM. Okay, LCM. Okay, since the HCF is a factor of all the given numbers and LCM is a multiple of all the numbers, the HCF would also be a factor of what? LCM. The other way around, the LCM has to be a multiple of HCF. Obvious, no? The LCM has to be a multiple of what? HCF. Okay, we'll try to write down a question. So please write down a question. The HCF and LCM of two numbers is the LCM and HCF of two numbers is 45 and 300. Okay, 45 and 300. If one of the numbers is 225, find the other number. Okay, find the other number. Guys, we blindly know one point, product of two numbers is equals to LCM into HCF. So what you're going to do, 45 into 300 divided by 225, 45 ones, 45 fives, because 45 fours 180, 45 fives 225. Okay, so 5 ones are 5 6 30 and 60 is going to be the other number. Okay, 60 is going to be what? Your other number. But guys, what are the numbers we encounter? 225, 60. Guys, tell me, what is the HCF of 225 comma 60. 45 is a HCF? No, 60 is not a multiple of 45. Then how it's going to be your HCF? Yes or no? So don't be in a trap of the, don't, fall for the fundamental error. Okay. Okay, guys, I want you need to understand few things here. Okay, so, but HCF of 60 and 225 is not, if you calculate 225 and 60, the HCF must be what? 15. And the LCM must be what? 900. Yes or no? So it's not 45 and 30. There is nothing wrong with the 0.1 above. Yes or no? It remains valid for all the cases for two numbers. Okay. In this case, the data itself is inconsistent. Are you getting my point? There is nothing wrong with the 0.1. Okay. It remains, valid for all the cases for two numbers. In this case, the data itself is inconsistent, guys. If HCF of two numbers is 45, then LCM of the two number has to be multiple of 45. That's what we are talking about now. HCF is 45. Okay. And point is what? Definitely your LCM is multiple of what? 45. No? But 300 is a multiple of 45. No. Yes or no? 300 is not a multiple of 45. So in this situation, just not possible, the answer is not possible. For this question, what is the point? The data is inconsistent. Okay, the data is inconsistent. I hope you understand. Please don't fall off these particular points. Okay, let's go to the next one. The HCF of a set of numbers is equal. Okay, these type of points you can learn. Okay, so now there is a fourth point. Sometime he is going to ask you 5 by 3, 4, 6 by 4 and 7 by 5. Find the LCM, and he is going to ask you find the HCF. When the numbers are which are in fractions, then how we are going to do? So simply what you are going to do is HCF is going to be, HCF of fraction is going to be HCF of numerators. Okay, HCF of numerators by LCM of denominators. Okay, LCM of denominators. Okay, if you want the LCM of the fractions, what are you going to do? LCM of numerators. Okay, LCM of numerators by HCF of denominators. HCF of what? Denominators, guys. So let's do this. We'll calculate both. 5, 6, 7. 5, 6, 7. HCF is what, guys? 1. LCM 3, 4, 5. LCM is what? 5, 4 is a 20. 23 is what? 60. So you can say the HCF must be 1 by 60. Okay. Okay. If you want the LCM of the numerators. What is the LCM of the numerators? The numerators must be what? 5, 6, 30. 30 into 7, 210. Yes or no? Are you getting my point? Okay. Okay, so if you 210 divided by HCF of the denominator, what is the HCF? That's going to be 1. So then the answer is what? 210. Okay. So this is how we can end our LCM and HCF, guys. We covered all the methods, okay, which come under into LCM and HCF. So please be patient and according to the rules, don't fall in a trap. Okay. So I hope you got your thing. That's all my time, guys. Thanks a lot for being in my session. Have a great day.